Okay, let's get it going. Thank you all for coming, especially at 9 a.m., the morning after a party. I think we should all start by giving ourselves a round of applause for getting here. I know there's probably some hangovers in the crowd. I think I'm in that category too, but luckily I have the Starbucks here to help me out. I'm Shyam Pather. I'm a development manager in Microsoft's data and modeling group. This is a session going to be about accessing data in .NET web applications. So in this talk, we're going to look at all kinds of data access. We're going to start from simple and then look at some fancier things as we get further in through the talk. But the way this is going to be structured is we're going to start out by looking at the .NET data access basics, kind of what's the simplest way you can get started building a web application on .NET that does data access. And then once we've established that, we can go look at some techniques and some tools and some patterns you can use that actually help you take those applications that you may build quickly and set them up for success in the long term, enable you to actually get them, evolve them, grow them as the requirements change, features change, and so on. And after that, we're going to take a look at some models. Unfortunately, the models we're going to look at are going to be sort of this sort of model, not this sort of model, but we'll try to make it entertaining regardless. For those of you who are concerned about the family friendliness, I can take my OData sticker here and help this lady out a little bit here. And now we can edit the video with the family friendly version of that. So speaking of OData, we're going to look at OData at the end. So if you were at the conference at all yesterday, you probably heard a lot about OData. And we'll take a look at how you, when building a web application, can actually take advantage of data sources that expose OData and use that data in your applications. All right? So with that, let's begin. So to start with data access basics, I thought what I'd do is jump right into demo. We'll write a little bit of code, and then we'll look at the patterns that we established doing this code. So I'm going to switch over to Visual Studio. And what I have here is the Visual Studio 2010 release candidate, the one that's out there for you to download and use today. And as you know, this will be shipping very, very soon. So we're going to start from scratch in this demo, and we'll do a file new project. And I'm going to pick an ASP.NET MVC empty web application, and I'll click OK. So just so I have an idea of who I'm talking to here, how many of you have used ASP.NET MVC before? OK, it's about half the room. How many of you consider yourselves experts on MVC? Okay, fewer people. So I'm going to go through some of the basics here, but specifically focus on how we use MVC with data access. And some of the stuff I'm going to show you in the beginning may be stuff that looks very different from what you've seen in other MVC talks, but hopefully it'll all converge by the end. So for context, what we're going to do today is build an application over a database that I have here on my local SQL Express. So we are in Vegas, so I have a Vegas database, and that Vegas database has in it some tables that really just contain information about shows that are playing in town. So I've got a shows table, a venues table, a performers table, and then a show performer table that really is just a link table that associates shows with performers, right? So we're going to use the same database over and over and look at different types of data access that we can do over this. So let me close down the magnifier, get back here. So I created my project, and what I've got here is an empty MVC app. And so I'm going to start out doing the simplest path possible to get a web page up with data access involved. So I'm going to add a new item to the page. It's going to be an MVC view page, and I'll call it default.aspx so that it's the page that gets started when we hit the root of our website. And as you can see, I get basically a blank template that looks like an HTML document. So it's an ASPX page, and as you know in ASP.NET MVC, you can actually stick some code in the middle of this HTML that will run on the server and dynamically build up parts of the HTML that will get sent to the client. So let's get started with this. So what we're going to do is start out by just getting some basic markup in place. So we'll create a div for our headers where we can put our heading. We'll put an H1 in there, and we'll say, welcome to Las Vegas. And we'll maybe put another div where the main content of the page goes. And in here, we'll put a heading that says shows, because we're going to show a list of shows, and then an unordered list where the show data is going to go. So what I'm going to do is actually put some code in here that's going to create a bunch of list items for the various shows that come out of my database. So before I get started with the data access, first thing I need to do is go create a connection string. And as you know, with ASP.NET, those typically go in the web.config file. So we'll go in and just put a connection strings element in. We'll add one. We'll give it a name, Vegas SQL. And the connection string for that, I'm doing this against my local SQL Express. So we'll do that. We want to target that Vegas database. And I want to use Windows integrated security. So we'll just say integrated security equals true. Now I can go back to my page and start writing some data access code. So the first thing I'll do is import the namespace where my data access APIs live. So I'll put an import directive up here. And if you've done any data access on .NET, you're probably familiar with the system data namespace. And when we're dealing with SQL Server, system data SQL client. We'll just put that up there. And now, right in this block of HTML, we'll go put some data access code. So in here, the first thing we'll do is go grab that connection string that we just put in the web.config. So we'll go to the configuration manager, ask for its connection strings, grab the one called Vegas SQL, and get the connection string property from that. Now we can use this to actually create a connection. The way we do that in .NET is we do a using statement, and we create a new SQL connection, passing in that connection string. And by putting it in a using block, we ensure that the connection and the resources associated with that get closed by the time we get to the end of this. So in here, we can, of course, open the connection. We can create a command object associated with that connection. And then we can set the command text. And in this case, I'm just going to select star from shows. And I know we should never do select star, but for the sake of getting going quickly here, I'll just do that. We probably want that to be shows, plural. And now we can go execute this command. And the way we do that is in a using block, we go obtain a data reader. So we can say command, execute reader. And in this, we can start reading through the rows that come back from the reader. So we can call the read method in a while loop. That's going to go through the results that come back. And now here, we can use those results to go build some HTML. So I'm just going to drop out of the code context here and put in that list item that I want to go create. So as it executes this loop, it's just going to be dropping these list items into the HTML. And in here, we'll go to the reader and ask for the show name property. All right? So let's take a quick run at this. It's going to prompt me to enable debugging in web.config, which is fine. So we'll get this going. And we should get our welcome to Las Vegas and a list of shows that are playing. Okay? So that's the simplest way we can get data access going. Now, before we move on, we're in Vegas. We're at MIX, and there's probably some designers in the room. So I'm going to make this a little more pleasing to look at, because we're going to look at this a lot during the course of this, this talk. The way I'm going to do that is I'm just going to drop in a CSS that I already have pre-prepared. So we'll grab an existing item. I'm going to grab my CSS and a little background image. We'll put that in our project. And then going back to the top of this page, I'll just drag the CSS on here so that we establish the right link. And now we can do it again, and it should look a little bit more like we're in Vegas. Don't I get some applause for my Vegas background or something? Okay. Now, I'm fully aware that my design skills are not exactly top-notch here, but this is what you're going to have to live with for the next 50 minutes or so. All right, so let's go back, and we'll switch back into the slides. So what you just saw there was the basic ADO.NET patterns. And these have actually been around since ADO.NET 2. The basic patterns are you create a connection, put it in a using block, create a command, execute that command, work through a data reader. The connection strings that configure how you get to your database go in web.config. And this gives you simple streaming access to data. And if you're just trying to get going quickly and build an application that does some data access, this is actually a fine way to go. And you could actually stop there. But if you're like me, there's often times where you start building something quickly, and then it starts to live for longer than you thought it would, right? And that application needs to evolve over time, and you have to maintain it, and you have to add new features to it. And doing it the way we just did it, you can certainly do that. But what we're going to look at in the next section is some techniques that you can apply that will actually set you up for success a little better as you have to evolve these types of applications. So specifically, we're going to answer the question, where should the data access code go? In the last example, we just put it right up there in the HTML, but we're going to look at some other options here. In particular, we're going to look at the MVC pattern. So MVC stands for Model View Controller, and what it's really about is separating the different concerns of your application into clear and distinct layers. So you've got the model layer, which is really just encapsulating the data, the core data that your application is dealing with. You've got a view, which is dealing with presenting that data to the user in some beautifully designed way, like my Vegas background there. And you've got a controller, which is really kind of a mediator between the two. The controller is the thing that receives a request, like show me the list of all shows. It goes to the model and asks for all the show data. It passes that to a view, and then the view can actually render itself based on the data in the model. Now, focusing specifically on data access, it should be pretty clear from this that data access really belongs in the model layer, because that's the concern related to data. Now, there's two patterns or recommendations that I want to leave you with when thinking about how to implement model layers within an MVC application. The first is to use the repository pattern. And all that means is you write a class that we call a repository, and you put all of your data access code in that repository class. So the rest of the app, like the controllers and the views and so on, never actually need to know anything about how that data access is implemented. All they do is call these methods on the repository. So that's recommendation one, use the repository pattern. Number two is use POCO classes to represent your data. So POCO, who knows what POCO stands for? A few people? OK, POCO means plain old CLR object. What I mean by that is, rather than passing up data readers, for example, like we did in the last one, and using that to obtain the properties of the data, create a little simple class. And that class doesn't have any code in it other than just enough properties to describe the shape of your data. And we'll use that to move data around through the different layers. And those classes, because they're just POCOs, they actually shouldn't know anything about how the data access is implemented. That's why we call them persistence ignorant. When you have an application like this, what you'll find is you'll have an easier time evolving it. You're able to say, let's say you decided you wanted the app to look totally different. It's hard to imagine, given my awesome design skills there, but let's say you wanted to change that. You could just go in and change the HTML in the view and not touch any of the other pieces. The way we just built it in the previous example, it'd be pretty hard to make a substantial change to the way the application looks without touching any of the data access code that was in between. So this is a pretty good way of separating out the different parts of your application. And as we'll see in a moment, it's actually relatively simple to do, especially with some of the help that ASP.NET MVC gives you. So I mentioned before the idea of POCOs and using POCOs to represent the data in your application. So there's two things that you might be wondering about. So where do we get these POCOs from? The first is, who actually defines these POCO classes? And there's really two options. One is you can handwrite them. And that's actually a perfectly fine way to get started. And if you have a relatively small model, that's not a terrible option. There's also various techniques you can use to generate those POCO classes based on, say, the schema of your database or a model, as we'll see later on. We'll look at some examples of that. The second question is, OK, once I've defined those POCO classes, who actually creates instances of them? And again, there's two options there. The first is, given the data reader, that same piece of code that we did before where we executed the command and then looped over the results, we can instantiate these POCO classes sort of by hand inside that data reader loop. We can also use a feature of the ADO.NET Entity Framework called Execute Store Query of T. And we'll look at this in just a moment. Think of this as kind of the first piece of the Entity Framework that you might want to use in an application. It doesn't require you to buy into ORMs or modeling or anything. It's actually a very incremental step above the straight SQL data access that we just looked at to a way to get strongly typed objects out of your queries. So enough talk. Let me go in and actually show you what I mean by all this by going into some code. OK, so here's the app we just wrote. You'll notice here, because we are using ASP.NET MVC, we already have some stuff, some folders in here for models, views, controllers, etc. And this is really because the whole framework is designed around this pattern. And that actually helps you out a lot when it comes to building applications. So let's start from the bottom. Let's start with the model layer. And we can go in here and add a new class. And the class we'll add, because we're dealing with shows, we'll call it a shows repository. All right, so we'll create a class for that. Now, before actually writing the repository methods, let's handwrite our POCO class that we'll use to represent show data. So I can write a public class show. And in this class, we'll put the properties that we know belong on a show. So a show has an ID, which has a getter and setter. It has a string show name, also has a getter and setter. And we're actually done at this point. So notice this class doesn't have any behavior in it. There's no code. It's just a simple little container for the data that we're going to bring up from our database. Now we can go in and actually write the repository. So first, let's write a method that's going to give us the list of all shows. So we'll write this as a public IEnumerable of show. So it returns a collection of show. And we'll call this getAllShows. And now inside this method, we're going to do our data access. And we can actually steal a lot of the code that we wrote in the previous example, because the patterns are really the same. The fact that we've moved to MVC doesn't change much in terms of the shape of the code. So we'll take this, we'll paste it in. I'll fix up a couple things, like let's get rid of this HTML stuff in here. We'll format this a little better. And you'll see I've got a couple of red squigglies, and that's mostly just because there's namespaces that I need to put using declarations for into this file, and now I'm good. But you see there's still a red squiggly line above the getAllShows, and that's because I'm not returning yet the shows that the signature promises there. So let's create a new list of shows, and that's going to be our results. And at the end of the function, we'll just return those. And in our data reader loop, so same code as before, we connected, executed the command, and now we're looping over the results. Instead of building HTML here, we'll take the results, and we'll add to it a new show object. And I can use the new C# property initializer syntax to just set the properties right in line here. So the ID is going to be the int that we get from going to the reader and asking for the ID property. And the show name is the string that we get from going to the reader and asking for the show name property. And then we'll just close this off, and then I think we're done. Now, if you look at this, there's data access in here, obviously, but the rest of the application doesn't know anything about that. All it sees is this getAllShows method that returns an IEnumerable of show. There's nothing specific about data access that leaks out of this. So we can now build the other layers of the application, and we're safe that the data access is hidden from those. So we'll go to the controllers folder. We'll add a controller here. We'll call it a shows controller. And we'll write the action methods that are going to handle requests against our website here. So the first one, that index method, is the one that is going to get called when somebody hits the /shows endpoint of our application. And what this is going to do is just instantiate that repository. To do that, I need to bring in the models namespace for my application. We'll create a private member in here called shows repository. And we'll just new that up. And in the method, we can obtain the shows by calling into the repository, saying getAllShows, and then passing those back to the view. Now we can actually go in and build the view. So before I build the view, one piece that I want to show you is when we got started, I put in a couple of these divs and the link to the CSS. We're going to create a couple of views over the course of the project here. So instead of repeating that code every time, I'm going to use a feature of ASP.NET called master pages. So you'll notice in the views there's a shared folder. I can add a new item to this app here called an MVC2 view master page. And for those of you who don't know about master pages, all these are basically pages that define overall HTML and give you little places to slot in specific content for each page. So in this case, I want every page in my app to link to this same CSS. So we'll drop that in here. And I want them all to have those two divs that we created at the very beginning, the header and the main. So I'll just take those and drop them in right here. Okay? And this content placeholder guy is what's going to get replaced by each individual view that we create. So let's save that master page and quickly build the project to make sure we're all good. And now let's go in and add some views. So in the views folder, we're going to create a couple of views for shows. Oops. So let's actually start by creating a folder for those. So we'll create a shows folder. In MVC2, we could actually do this with areas as well, but for now, we'll just do it the old way. And in here, I'll add a new view. And the view we're going to call index. I'm given the option to create a strongly typed view, meaning that view actually knows about the shape of the data that it gets, in this case, it's going to be bound to the show class. And the view content is going to be a list. And I'll click Add. And this is actually going to build me a view that has some HTML in it. And that HTML you can think of as basic scaffolding for the UI of my application. So if I actually run this, you'll see what got created. When I navigate to the, oops, that wasn't what I wanted to do, to the shows folder, what shows, plural. There you go. This is the view that actually got created for me by ASP.NET without me having to do anything for it. So what's going on here is when I hit this shows URL, ASP.NET by default goes and looks for a controller called shows controller. It says, what am I doing? Well, I'm hitting the index page for this. It goes and calls the index method. Our index method is the one that actually invokes that controller invokes the repository to go get the show data. And then it returns the view. And it looks for the index view that we just created and binds that all up. Now, of course, the view that was created is just a starting point. We can actually get rid of this markup and do it our own way. That may be a little better suited to what we want to show. And as I'll do this, I'll describe how the view and the model interact. So we got rid of all the markup there that was generated for us by the system. And so we'll go make this look like the page that we started out with. So we'll call it shows. And just to distinguish from the other one, we'll make it clear these are shows that came from the database, from MVC at least. The other ones came from the database too, but that's fine. And then in here, we'll put the unordered list that we had before. And we can here go into a code block. So before, I put data access code in here. In this, I don't have to do that. I can just, for each show in the model. Now, model is a property of the page. And if you actually hover over it, you'll see that it's actually an instance of that show class, or it's an IEnumerable of that show class that I created before. So in here, we know the shape of the model. We can go in and actually just break out a code context again and create those list items directly. And in here, we can say show.showName. And there's one other thing I recommend you do. So this would actually work if we ran it. There's a helper method which you should really use called html.encode. And what this will do is ensure that whatever the characters are that came back from the database are encoded properly to live in an HTML page. So if there were angle brackets there or some nasty script or something, it would take care of making those show up right. So I think I can just refresh this page. Let's just try that. There it is. And now it looks like the page that we had before. Okay? So we took the app that we had that was all inline. We did the MVC dance over it. So we got a view now that only knows about the model. We got a controller that only knows about the repository. And we got a repository where all the data access is hidden. And this is a good separation so we can clearly go change any of these pieces without affecting any of the others. So that's the basics of MVC. And as you can see, the basic patterns aren't really that complex. One thing I touched on earlier is this idea of how we instantiate our POCO classes. So I'm going to show you another option for that in a moment. So if you look here, what we're doing is we're by hand newing up these show objects as we go through the data reader. As I mentioned, there's a little piece of the entity framework that you can use here to actually get these classes instantiated for you without having to do any work in terms of the code that you write. So let's take a quick look at that. Later in the talk, we're going to look at the entity framework in a little more detail. But for now, I'm going to just kind of show you the first thing that you can take advantage of when using that framework. So we'll add a new item to our models directory. We'll go to the data field, and we'll say entity data model. And we'll call it vegas.edmx. And we'll point it at the Vegas database that we already have, and click Next. And this entity data model wizard is going to give me the option to take my entire database schema and bring it into a full model. And we're going to do that later on. But for now, I'm actually going to not select anything here. And it's going to give me a warning that I'm going to create an empty model. And that's fine, because it's actually what I want. What I'm doing is I'm creating this blank model just as a way to get started in the entity framework. And it's got nothing in it, so I can actually even close it, because it's not really interesting. The only interesting thing is the CS file that got dropped behind it contains this class called Vegas entities. You don't really actually even need to worry about what's in this right now. Just think about it as a class that you use when you want to start a strongly typed interaction with your database. So having built that, let's go back to our shows repository and look at a way we can take advantage of the entity framework to make this code a bit simpler. So if you look at this, what I'm doing is creating the results. And we'll keep that particular line of code. Actually, before we dig in here, let's instantiate that Vegas entities class, because that's the one that we're going to be using throughout here. So we just created a new instance of that in a private member. And I can actually now get rid of pretty much all of this code. And instead, what I can write is I can say context, execute store query, and it's execute store query of T. So I can say execute store query of show, meaning show is the class I want you to go materialize from the results of this query. And then I can actually just put the query right here. And finally, I can call toList to take that query result, actually stream through it, and build up my results. And I can hit go. And when we go to the shows page, let's go to shows, there it is. You see the same data as we did before. But look at the difference in terms of the number of lines of code. That execute store query of T method actually did all that ADO.NET work for me about creating the connection, opening it, doing the data reader dance, spinning up those objects. And I didn't have to do any fancy data modeling or ORM or anything. This is just a very easy way for me to get objects out of my database by writing any query. And in fact, in here, all I did was a select star from my shows table. You can write any SQL query there. Whatever the result shape is that comes back, the set of columns, as long as the type that you put in the T there matches one-to-one to that schema, you can use this as a way to get objects out of your database, right? Very low overhead way to do that and get started. So that's an option if you're working against SQL, you want to get objects back from the database. And you look, the code got a lot simpler. And I actually did here one of the things that I talked about before, which is I changed the data access code, and I didn't touch the rest of the app, and everything still worked. OK, so let's move on. So we basically saw there that when moving to MVC, we can still use the same basic ADO.NET patterns, but we just hide them within a repository. We'll make the repository return these POCO objects, which are then consumed by the controller and bound to the view. And finally, we can use execute store query of T to get objects from our query results in a really easy way. Now, we started down the entity framework road there, but we really didn't use much of the entity framework. In this next section, I want to talk about what you get by going down the road of using the entity framework and specifically using data modeling. A key piece of .NET that we added starting in .NET 3.5 is this thing we call the entity data model. How many of you are familiar with entity framework or entity data model? OK, good number of hands there. So basics here are entity data model is a way of describing the domain model that you want to work with in your application. The fundamental things in the EDM are entities, which are the things, and relationships, which describe how those entities are associated with one another. You can start by thinking of the EDM as a way to map one-to-one to your database. So each table becomes an entity. The foreign keys you have become relationships. But really, the entity data model is more rich than that. You can use it to introduce things like properties that are complex types on your entities. You can do inheritance, where one entity type derives from another entity type, and so on. You can describe properties that actually navigate across relationships, for example. And having done that, you can actually build a fairly rich domain model using this vocabulary. You can then map that either to an existing database or a new database. And when you do that, you can use the entity framework to then get data access over that model. So think about core ADO.NET that I showed in the first example as data access to your database. Think of entity framework as data access to your model mapped over your database. What you get by using the entity framework is the ability to write queries using link instead of using text. You can get POCOs for your results almost automatically through the framework. The objects that come back are actually change tracked, so you can change them and have those updates pushed to the database. And there's a variety of other features that you get by moving to this ORM. Now, beyond just the ORM stuff, you can get other services too. So the point I want to emphasize here is the entity data model is a really, really big bet for us at Microsoft, and specifically in the data group. You're going to see this EDM thing pop up all over the place across various servers and different technologies at Microsoft. And one of the first things that you can get by virtue of having a model is a really, really easy way to get an OData head over your application if you want one. And we'll look at that when we get into the demo in a moment. So if models are so important, how do I get one? There's three ways. The first is to start with a database you have and reverse engineer a model from that database. And the tools help you do that. You'll get a one-to-one mapping between your database and your model. And you can, of course, take that and then tweak it so that it's no longer one-to-one. But it's a reasonable starting point. And we'll do a quick walkthrough of that in this talk. There's two other options. The first is to actually start with that EDMX designer, the one that we brought up that was blank before. And you can actually drag on new entities from the toolbox or from the design surface. You can fill out their properties. You can draw lines between them to establish relationships. And actually start from a blank slate, build up your model that way. Then you can either map that to an existing database that you have, or you can use this new feature we've added in Entity Framework 4 that lets you actually generate the database from the model that you built. So if you're someone who likes to think about the domain model first and you're building a new app, this is a very useful way to get started. You can draw your model explicitly and then have all the DDL, the create tables and all that, generated for you by the framework. I'm not going to have time today to walk through that, but the link that I put up there is for a Channel 9 video that Jonathan Carter did that walks you through the model first experience. So the last option, if you're somebody who, you're just writing code, you don't actually care what the database looks like, you don't want to think about this model thing, you can actually do all of this just with .NET classes. So you can write the little POCO classes that represent your domain model, and you can have the model itself, as well as even the database, if you want it, generated for you by the entity framework. And again, that's not something we're going to have time to look at here today, but the link that I have there is for a blog post on the team blog that walks you through the details of that and shows you what that experience is like. So those two are new features, and hopefully give you some different ways to get started with modeling. So let's go into this back into Visual Studio, and we'll do the model thing real quick. And so to motivate what a model can do for us here, let's actually just go back to the database that we had that we looked at before. So I'll zoom in here. So here's our Vegas database, and here's the tables that we have. So let's think about what we need to do to go build a page in our application that instead of showing the list of all shows like we just did, a page that shows the details for one show. So give me the show, the name, where it's playing, what the venue is, the list of all performers, and all that. So relatively simple thing that we have to do. And we've got a pretty much ideal database schema here, where I've got shows that have a foreign key to venue. So if I wanted to find the associated venue, I can just navigate that foreign key. If I want to find the associated performers, I can go to this link table that has a show ID, performer ID. So pretty great database schema for what I want to do. Let's look at, if we were just working in SQL, what query we'd have to write to be able to achieve what I'm talking about. So let's close this. So what I'm looking at here is the query designer in VS 2010. And let me just get rid of some of these pieces to make it a little easier to see. And this query is a little bit complex, so I'm not going to type it. I'll just put it in here. And let's zoom in a little bit so you can see what's going on. So in this query, I'm having to select from shows, join with venues. I have to do this left outer join and a subquery to deal with that link table. And then finally, filter by ID. So if you think about it, like what we talked about is just go find the associated venue and performers. This is kind of a complicated query that we have to write. But this is what we have to write if we're working just in the relational world. So one problem here is the query complexity. Another one is dealing with the results. So you saw before, there's that data reader loop that we can do to go materialize our results. Let's take a look at what that would look like for this query. So I'm running this here, and it prompts me for a value for the query's parameters. In this case, there's an ID parameter. So if I query for ID 1, the results are not too terrible, right? There's an ID and a show name, a venue, a performer. And I could take this, and I could new up a show object, a venue object, a performer, and set references to go build them. But let's look at another one. So here's one with ID 3. So here's actually one show, but it has two performers. So because I had to do that left outer join, we get two rows back. And it's a little more complex now where I got to remember there's really only one show object and one venue object, but a bunch of different performers. And if I look at one more, here's a show that has no performers. So now my code has to be able to deal with nulls in those columns. So you can see very quickly when you're working just with the database, some of these tasks that ought to be really simple start getting kind of complex. So thankfully, having a model actually saves us from a lot of this pain. So let me go back to our Vegas EDMX. And it's blank at the moment. And what we'll do is actually use the tools to go build a real model from the database. So here I chose the update model from database option. I could, of course, have done this in the first place when I first built the model, but I wanted to do it in 2 steps to show you the minimum way to get started. So here I'll select all the tables. And what this is now going to do is actually interrogate the schema of the database, figure out what the relationships are, what the types are, and so on. And now I get a full EDM here in my Visual Studio. So if you take a look at this, one of the things you'll see is I had 4 tables, but I really only get back 3 entities. The reason is it was smart enough to know that that link table really just represented this many-to-many relationship between show and performer. And there's a one-to-many relationship between show and venue. So because these relationships are now nicely captured in my model, and the entity framework gives me a way to query over that, the kind of code I have to write to do the things that I was just talking about becomes a lot simpler. So we're going to write that code in a moment. First, let's actually use the tools to get some POCO types that correspond to this model. So remember before I wrote out the show type, and I could certainly write out a performer and a venue type here. But I'm going to illustrate to you a new feature that we added in Entity Framework 4, which is code generation through templates, through T4 templates. So I right-clicked on the model, chose Add Code Generation Item, and you can see I'm given a set of options here for different templates I can use to generate my entities. If you install Visual Studio out of the box, you'll see this entity object and self-tracking entities templates. The POCO template is one you have to grab from the online gallery, but it's there and it will be available the day you. It's certainly there for the RC. It will be available the day this product RTMs. And I'm going to pick that one now because that's the I want POCO shapes in my project. So I'll add that. And what that's going to do is go into Solution Explorer. I'll see that there's a Vegas TT and a Context TT that have been added. Let me just save my model here so those templates actually have the right data to run over. The Context TT is just going to create that Vegas Entities class we already saw. But Vegas TT actually contains the POCO classes for my types. So if you look here, here's a show class. And it looks very similar to the one that I wrote before, like it's got just the properties in there. Notice there's no base class or any complex code in here. This is just a simple POCO class. So I can now use those to code against my app. So that's a code gen way to get POCO classes that you can work with. So if I build at this point, you're going to see I'm going to get a build failure. And that's because my template generated a show class for me, and I also had one in my code. So I'm going to delete this. But before I do, I want to be 100,000% clear about a point here that it might easily be confused. I'm going to delete this class that I wrote and use the one that was generated by the framework, just because I don't want to spend the time in the demo to type out the other ones. You do not have to use the code-generated POCO classes. You can write your own POCO classes and use them, and the entity framework works just fine with those. I'm going to not do that here just because I want to save some time in the demo. So I'm going to get rid of that. I can compile this, and actually the app would continue to run against my existing code would continue to run against those POCO classes. But let's go in and write the next repository method here. So we wanted to get the details for a show. So we'll write a method that returns one show, and we'll call it getOneShowDetails. And it's going to take an ID. Oops. And in this method, we'll write a query. And because we're in the entity framework, we can now use link. So we can say from s in context.shows, where s.id equals the ID I was passed, select s. And then I can return from the query the first results. Right? This query is only going to return one value. We call first to get that out. So there's our details method. We can go to the controller, and we can write a method here that will get invoked. So it's going to be called action result details, and it's also going to take an ID. And this method will get called when we hit a URL like /shows/details2. Okay? So in here, we'll just go back to our repository. So we'll grab the show by calling the repository, saying getOneShowDetails, getting an ID, and then returning a view with that one show. So we need to create that view. So going back to our views folder for shows, let's add a new view there. And this one we'll call details. And again, we're going to bind it to the show class, but we'll start out with an empty view. We'll click add. And I'll get rid of this. And I actually have a snippet here, so you don't have to watch me typing the view. But all this is doing is it's doing a header that says details for this show name. And here my model is just a single show instead of the collection. So I can get to that show name. It's going to print the venue and then the venue name and street address. And notice to get to that venue, all I did is I just touched this venue property on the model. When I wanted to get the performers, I just hit the model and went to the performers property and spun through those and printed out a list of those. So let's take a run at this and just see what it does. So we're going to start off at the root of the site, but let's say we wanted to go to shows details 2. And there's the details for the Lion King show. So everything I did there was strongly typed. I was able to navigate those relationships just by touching those properties. And one quick thing I want to touch on here. You notice in my repository, I just did a query for shows. I never actually explicitly told it to go bring back the related venue and performer. I could, of course, do that by putting a .include over here. But new feature in Entity Framework 4 is lazy loading. So when I wrote this view, and when I touched venue and I touched performers, the framework knew to actually go fire off a query to go get those related entities. I didn't have to think about that. It just did it for me. That's one of the new things you get when using Entity Framework 4. So let's move on. So we're getting short on time here. I mentioned one of the things that you get because you have a model is a very easy path to getting an OData head over your application. So the way we do that, if you want an OData head, so hold on. How many people in the room know what OData is? All right. So whoever had their hands down, I guess you were in your hotel room the entire day yesterday. It's pretty hard to miss at this conference. So let's go in here. We'll add a new item. And the item we're going to add is going to be in the web category. We'll scroll down, and you'll see there's an item here for a WCF data service. So for those of you who may have been familiar with the ADO.NET data service item template before, this is really the same thing. It's just been renamed to WCF data service. So we'll go in here. We'll call this Vegas.svc. And that's going to drop into my project a class called Vegas, which inherits from data service of T. Now you'll notice my T isn't filled out here, so I need to go put some code in there. To do that, I'll just bring in that model's namespace. Now because I created that EDM and I have this Vegas entities strongly typed class, I can just put that in there. And what that means is build me a data service that exposes that Vegas entities model. All right? So that's basically what I need to do. I need to do two more things. One is in this initialize service method, I have to turn on what data I want to have exposed. So obviously, I don't want to start by doing one of these things and now all of a sudden my whole database is exposed on the web. What I can do is actually explicitly set access policies here. So what you'd really want to do is think about which entity sets you want to expose completely, which ones for read-only, which ones for read-write, and so on. So I'm going to do the thing that you should never do, which is to put a star in there and just expose everything. So just remember, you're not allowed to do that unless you're in 14-point font up on a giant screen. It's the only place that that's allowed. And I'm glossing over it here, but there are other ways to control security even within entity sets with data services, so you don't have to worry about your whole database getting exposed. So this should be all the code that I have to write, but I am embarrassed to say there's a little bit of a bug in the product. So this is the last bug that we didn't quite catch in time. And because this bug is here, I have to write 3 extra lines of code in here that I wouldn't normally have to write. So I'm going to show you this so you know what the code is that you have to write. But ideally, this is going to go away very shortly when we get a chance to fix this bug. And because I'm going to put you through the pain of watching me do this painful piece of code, I'm going to entertain you while I do it. To celebrate St. Patrick's Day, I'm going to tell you an Irish joke as I do this. Sound good? All right. So an Irishman walks into a bar, goes to the bartender, and orders 3 pints of beer. The bartender looked at him a little funny because he's one guy by himself and he's ordering 3 pints of beer, but he's a paying customer, so no problem, gives him his 3 pints. So the gentleman takes his 3 pints and he goes and sits in the back of the bar and he starts sipping from them. And he takes a sip out of 1 pint, sip out of the next one, sip out of the third. And the bartender says, you know, beers go flat pretty quickly, so why are you doing these one at a time? Or why did you order all 3? And he says, I have 2 brothers. One's in Dublin, one's in New Zealand. And we can't drink together. So what we do is we each go to a bar and we order 3 pints. And we take a sip in sequence like this. And it gives us a nice feeling that we're together even though we're not. So bartender thinks, OK. And this guy kind of does this regularly. And everybody thinks, you know, what a sweet tradition. But one day he comes in and he's looking a little sad. And he sits down and he orders 2 pints of beer instead of 3. And everybody in the bar is like, wow, this guy must have lost one of his brothers. This is really sad. So the bartender goes up to him and says, I'd like to offer my condolences on the loss of your brother. And the guy looks at him and goes, no, nobody died. Everything's all good. I just quit drinking. OK, so thank you for bearing with me. The reason I had to do this piece of code is I needed to do really this line here, proxy creation enabled equals false. It's just a little bug in the product. Hopefully that will go away. But if we start this up again, we can go to the vegas.svc endpoint. And you'll see here's an OData feed, right, or an OData service document. And I can go in here and I can look at, for example, shows. And there's my shows data exposed as OData. So I'm not really going to go into any details of this. There were talks yesterday, which you can view online if you didn't see them, that kind of just explain the semantics of this. But really, the point I want to make is because we had a model, we were able to create a data service of T very, very easily. Now, of course, there are other ways to create OData heads, but this is one benefit you get of having a model. You just get it spun up very quickly for you. All right, so let's go back to slides. We've got one more thing to look at, and then we're going to wrap up. So there's models. We talked about there's 3 ways to create an EDM from the database, on the design surface, or with code. The slide I had right before the demo had links to walkthroughs for the second 2. Once you have a model, Entity Framework gives you rich data access, rich ORM functionality over that. And you get other services, for example, an OData head, by building a WCF data service over your EDM. All right, so I'm going to just touch on the other side of OData now. We looked at how do we take a database that we have and expose it as OData. One of the things you'll see that there's more and more data sources out there, like Netflix and OGDI and so on, that are exposing OData. So you might want to actually build code in your application that consumes that. So what you need to know about OData is basically 3 things. It's a uniform way of representing structured data on the web using Atom and JSON. There's uniform URL conventions for doing things like navigation, filtering, sorting, paging, and so on. And there's uniform operations that you can do when you know how to address things, and you know how to get to them via HTTP verbs like get, put, post, and delete. And those verbs always mean the same thing, regardless of which OData endpoint you're looking at. So what I'm going to do next is show you how on .NET you can very easily consume an OData service, and in this case use it in a web app, although you could certainly do the same thing in a WPF or other type of app. What you do is you add service reference, much like you're probably used to if you've done any work against a WCF service, and that generates some proxy classes that you can use with the WCF Data Services client library to go access that data source. The patterns for doing that are very similar to the Entity Framework. They support link for querying, and they fit easily into the repository pattern that we already showed. Now, this is not just a .NET or a Microsoft thing. There's many other clients for other platforms as well. So you can do this even if you're on other platforms. But here we're going to look at the .NET one. So let's look at an example. So I'm going to pick up my browser here and show you an OData service that's been up through this conference. So I'm going to the Visit MIX site. And you may have seen this if you were in any of the demos before, api.visitmix.com. There's an OData service at that location that actually exposes all of the session, speaker, tags information from the session catalog as an OData feed. So we can go into here, for example, and look at sessions, and here's the session data. Now, let's look at what it takes to go consume that type of feed in our application. So let's say we've got this Vegas app, and MIX sessions are an important thing going on in Vegas. Let's take a look at how we can give some information on our website by using this OData feed. So we'll go and add service reference. We'll pick that same API visitmix.com URL, and we'll click Go. This is going to go find the metadata for the service. It's going to know that there's files, sessions, speakers, tags, and so on. And I'll click OK. And that's going to bring a service reference into my project. There's one little thing I need to do here. Again, it's because of a little small bug. Unfortunately, I don't have an Irish joke for this one, so if anybody else wants to step up, they're welcome to do so. This is going to be real quick. I just need to put a little piece of code in here and go back, update my service reference. And I should be good to go. All right. So now, if I look at the service reference, you'll see that there's a bunch of classes in here that correspond to things like the session or the files and tags and so on. And I can use those directly in my project. So let's go ahead and do that. So again, we're going to follow the MVC pattern. We're going to go to our models. And instead of the shows repository, let's add a sessions repository that knows how to get to session data. And again, because I'm doing this in a repository, the nice thing is I could get this from OData, and the rest of my app doesn't need to know that that's what's going on. So let me bring in here my service reference namespace, as well as the namespace for WCF Data Services, which is System Data Services Client. All right? So you remember in the previous example when we were using Entity Framework, we created a Vegas Entities context class as a private member. I'm going to do the same thing here. And now we're going to return a collection of sessions. We'll call this get all sessions. And in here, we can go to our context, and we can say sessions, and we're going to return all of them, so we'll just say toList. All right? So that's now going to give us a list of sessions. One of the things I'll do, you'll see there's a red squiggly line here. When spinning up a context for a data service, I actually need to provide the URL to that data service. So I put a new URI in here. We'll go to the browser so I can steal the URL. So the URL you give is the one that points to the root of the service. We'll do that. And we'll go to the beginning. And we should be able to build that now. So now we have a sessions repository. So real quickly, we can do a sessions controller. And not much is going to be different in this one compared to the previous one. So we'll just bang through it. So we'll need that model's namespace. We'll new up the sessions repository here. And in the index method, we'll just return the repository's getAllSessions results, which is going to be an INumerable of sessions, or list of sessions. And of course, we need to do a view. And don't worry, I'm not going to go type a whole view in here. I've got a snippet for it. But let's create a folder for sessions. And let's create an index view here. Strongly typed again. And this time, it's not typed to show. It's typed to session. And we want it to be a list, actually. We'll click Add. And then let's actually get rid of the scaffolding in here. This one's a little bigger just because session has more properties than the show that we looked at earlier. And I'll use my snippet. All this is doing is it's printing a heading. It's spinning through the model. And for each session, it's printing a title and the body element, which contains the got some code errors here. Where is it pointing? Oh, here. There we go. Let's try that again. So now, again, using the same URL routing method, if we go to sessions, we're going to hit that page. We'll go to our controller. The controller will invoke that repository. And here you see all of the MIX session data included that it obtained from OData. So one very tiny thing I just want to show here before we end off. I mentioned before that the client library supports link. So in here, where is my sessions repository? Here we go. Here I just ran a query over all sessions. I could do something different. So let's say I wanted to do a cutoff, right? So I want to find sessions that are after 3/17/2010, 12 p.m. or 12 a.m. p.m. is what I want. Okay, there we go. I can define a cutoff. And now I can write a query that says from s in context.sessions, where s.startTime greater than or equal to my cutoff, select s, and then I could return this query to list. And let me just set a breakpoint here because there's one interesting thing I want to show. So we'll get here. We'll run sessions. And that's going to fall into my code. So notice I wrote a link query. But if I hover over this guy, you actually see the URL that it's going to execute. Let me try that here with you can see there the URL that it would have hit against the I can't really do it in this magnifier very well, against the service, right? So all it's doing is it's taking this link expression and building a URL out of it. So again, we're using that REST interface. All right. So we'll let that finish. And now you'll see there's fewer sessions in here because they're just the ones that come after noon. All right. So let's quickly go to the slides, wrap up. So we showed you OData access there. Add service reference is the key to getting started with the .NET client library. You'll get similar patterns to the entity framework, link querying. What I didn't show here is those objects that come back can be change tracked as well so that you can push updates back to the service. And even though you're doing OData, you can still use and should use the repository pattern to encapsulate that. So to end off, I want to just do the call to action here. So first thing is, I showed you a lot of options for data access. We have a new data developer site on MSDN. I encourage you to take a look at that. You can learn a lot more about the entity framework, about ADO.NET, about WCF data services, all starting at that point. The bits that I showed you today are available in the .NET 4 RC. Go grab that, give it a spin, and learn more about OData. Go to odata.org to do that. And I'll take questions, but just so you know, there's some people in the back who have T-shirts. I've got some OData stickers here. And with that, I thank you.